Exercise 4.3 question number 11. Integrate e raised to power x into 1 minus sin x over 1 minus cos of x. We can just simplify this function by breaking this x into half angle. That is, we can write in place of x as 2 multiplied by x by 2. Just replace x with 2 multiplied by x by 2 and here also. We know that sine 2 theta is equals to 2 sine of theta cos of theta, and cos 2 theta is equals to cos square of theta minus sine square of theta. This is sine 2 theta cos 2 theta. Just replace it using this identity. 1 minus this, due to this negative sign will be multiplied inside and we will get this denominator. 1 minus cos square of x by 2 can be changed into sine square of x by 2 by using this identity. Cos square of theta plus sine square of theta equals to 1. So sine square of theta is equals to 1 minus cos square of theta. So just replace 1 minus cos square of x by 2 with sine square of x by 2. Sine square of x by 2 plus sine square of x by 2 will be 2 sine square of x by 2. Now we have only one function in the denominator. Just divide it with this one and with this second function separately, and also multiply e raised to power x inside with 1 and with this function, and divide and split the integrals into two parts. We will get e raised to power x into 1 over 2 sine square x by 2 dx minus this minus sign e raised to power x 2 sine x by 2 cos of x by 2 divided by 2 sine square of x by 2. 1 by 2 is a constant. I have taken it outside. Now here this 2 will be cancelled with this 2. Sine of x by 2 will be cancelled with this. We'll get cot of x by 2 e raised to power x. Now we know that cot function has the derivative cosecant square, the same thing. So we will not just don't disturb this integral, just integrate this integral by parts and we'll get the same integral like this, and we'll just cancel this. So just integrate this part. This will be our first function because this will be our first function, and e raised to power x will be our second function. I have taken it first function because we know that integration by parts has the formula that first function into integration of second function minus main integral derivative of first function. So here we need cosecant square of x by 2 so that we can cancel this integral. So that's why I have taken it as first function. This integral is written as it is. Now using integration by parts formula, first function into integration of second function minus main integral derivative of first function is minus cosecant square x by 2 and derivative of angle is 1 by 2, and integration of second function is e raised to power x. Now open this, simplify it. Minus e raised to power x cot of x by 2 minus minus plus, and plus minus will be minus cosecant square of x by 2 e raised to power x by 2. Take this 1 by 2 outside like this. Now you see both the integrals are same. We can cancel them and we get minus this one. We get this in our answer, minus cot of x by 2 e raised to power x plus c. Question number 12. Arc tangent 1 minus x over 1 plus x under root. Arc tangent means tangent inverse. So our question is, we have to integrate tangent inverse 1 minus x over 1 plus x under root. For the simplicity, let's suppose x is equals to cos of theta, then dx will be minus sine of theta d theta. Just replace x with cos of theta. We'll get 1 minus cos theta or 1 plus cos theta under root. We know that this is the formula half angle identity of tangent theta by 2. This is a direct formula. If it is memorized by you, you can write it directly. This is the half angle identities. These half angle identities we did it in first year course in mathematics, first year trigonometry part. But if you don't remember this formula, we can just change it into this formula by using this half angle. We just replace theta with 2 into theta by 2. Then we will just 2 into theta by 2 and we'll just get this same form. And we can open it like this by using this same form, by breaking it into 2 into theta by 2 and just using this identity. And then using this identity, we'll get this formula if you don't know it directly. Now simplify it. A tangent inverse will be cancelled with tangent and we will left behind theta by 2 and minus sine theta d theta. Constants will be taken outside. We left theta sine of theta d theta. Now we know that theta on differentiation, it will be reduced. So I have taken this first function. Now first function into integration of second function minus main integral sign. Derivative of first function is 1 into integration of second function d theta. Open it, simplify. The integral sign will have cos theta, that is the sine theta. Now just simplify the terms. We know that our question was in x, but here we have theta, so just remove this theta in terms of x. Now we were having x is equals to cos of theta. We want the value of theta here. So we know that cos inverse of x will be equals to theta. Now we also want the value of sine of theta here. Sine of theta is equals to under root 1 minus cos square of theta. So this will be 1 minus x square. So just replace the value. Theta is cos inverse of x. Cos of theta is x and minus sine of theta is under root 1 minus x square. So this is our answer of this question number 12. Integrate arc sine x over x plus a dx. Just let suppose x is equals to a tangent square of theta. Take derivative on both sides. We will be left behind dx is equals to 2a tangent theta secant square of theta d theta. Just replace the values in this integral that you know very well. We did it earlier in the previous examples as well, that how we substitute the values. After substitution, just simplify this by taking a common. In the denominator, we will have tangent square of theta plus 1. And that is, we know that secant square of theta. So a will be cancelled with a and square will be cancelled with the square root, and we will have tangent theta over secant theta. Now open these terms. Tangent theta is sine theta over cos of theta and 1 over secant theta is cos of theta. That will be cancelled and we will have sine inverse sine of theta. This will be cancelled and we will get theta tangent theta secant square of theta. Now we know that tangent theta has the derivative secant square of theta. So if its integration comes, we can take its integration as tangent square of theta over 2 because it has its derivative with itself. Okay, now theta can be reduced by differentiation, so take it first function and this one as second function. First function into integration of second function. You know that this function has derivative with itself, so power plus 1 divided by that power. Minus derivative of first function into integration of second function d theta. Open the things, just simplify it. We will get this integral here. This can be opened as secant square of theta minus 1. And if we take its integration, secant square of theta will give us tangent theta and integration of 1 will give us theta. Open this all terms, simplify them. Now, our question was in x and we have it in theta. We know that we took x is equals to a tangent square of theta. We want theta here, value of theta here. X over a will be tangent square of theta. So, x over a under root will be tangent theta. So tangent inverse x over a will be equals to theta. So just replace in place of theta tangent inverse x over a. Now we need the value of tangent square of theta, that is x over a, replace it with here. And tangent of theta is under root x over a, replace it here. Theta again is tangent inverse under root x over a. So just rearrange the terms and we get this answer because a will be cancelled with this a and we got this answer of question number 30. Question number 14. Integrate e raised to power ax sine bx plus c. Both of them have integration formulas, but both of them when differentiated will not be reduced. We cannot say anything about them. So just take any of the function as first function and any of the function as second function. I have taken sine bx plus c as first function and e raised to power ax as second function. Let it equals to some capital alphabet. First function as it is into integration of second function minus integral derivative of first function. This is the derivative of first function into integration of second function. Now, b over a is a constant. Take it outside. We will have cos of bx plus c e raised to power x. You see, we just took trigonometric function as first and exponential function as second. Just give them the same naming. So trigonometric function will be first and the remaining will be second function. Just give it the same naming. Now open it by using the integration by parts formula. First function as it is, integration of second function minus derivative of first function into integration of second function. Just open this by multiplying it inside. We will have minus b a square e raised to power x cos of bx plus c minus minus will be plus and plus minus will be minus. This b when multiplied with this b will be b square. A multiplied with a will be a square. And the rest of the things will be written as it is. You see, this is the same question now. I equals to I. So just replace it equals to I. Now this is minus b square over a square I. Move it on the left side. This will become plus b square over a square I like this. And the rest of the things will come as it is. Now take I as common. We will left 1 plus b square over a square. Now take its LCM. We got a square plus b square over a square into I. Move it on the right now. A square is divided, it will be multiplied, and a square plus b square is multiplied, it will be divided like this. Now we know that we have some denominator a here that can be cancelled with this a square. So just multiply a square inside with this function and with this function. If it is multiplied inside, we will have here a, and here no a is present because this a square will be cancelled with this a square. So we got this answer of question number 14. Question number 15. Integrate ln x plus under root 1 plus x square dx. Now we cannot simply simplify this function. Just write 1 into ln x plus under root 1 plus x square. Now we have two functions here. Ln have no integration, so take it first function and this one as second function. Now first function into integration of second function. Integration of 1 dx will be x minus derivative of first function. Ln this function is 1 over that function and d by dx of that function. D by dx of this function will give us 1 plus derivative of under root will give us this, the differentiation into integration of x. Now x into ln x plus under root 1 plus x square minus, this is the same x here. Just take the LCM here. This 2 will be cancelled with this 2. We will have here 1 plus x over under root 1 plus x square. Take the LCM, it will be 1 plus x square plus x over 1 plus x square. So I have written it like this. This one, this is the same thing, and this is this one. Now this can be cancelled with this one. We got x over 1 plus x square under root. Now move it upside, we'll get minus 1 by 2. Now we can make its derivative here by multiplying 2 and dividing with 2 as well. Now this main function has its derivative here. So we can add in the power 1 and divide it with it as well. So after simplification we get 1 by 2 divided by 1 by 2. Now this 1 by 2 will be cancelled with this 1 by 2. We got this function and this can be written as under root 1 plus x square.